So in this problem we have event A, choosing a heart from a deck of cards. 13 hearts out of 52 cards gives a probability of 1/4. Choosing a prime number from a deck of cards, the probability is 24 prime numbers out of 52 cards, 6 out of 13. So the question here is, what's the probability of choosing a prime number and then a heart with no replacement? We do that by finding the probability of one of those events and then multiplying by the probability of the other event given that the first event has already happened. So the big question here is, how do we figure out this part of it? So we already know this one. In this situation, the question is asking, what is the probability of choosing a heart given that we've already got a prime? And so that's two different things. Either that could be 13 hearts chosen from 51 cards because we've already taken one out, or it could be 12 hearts chosen from 51 cards. 12 happening when the prime number card that we picked already was already a heart. And so because we have two possibilities here, we have to have an or situation where we add, when is it going to happen that we have this situation? When is it going to happen that we have this situation? So when will we have the prime card was a heart? How many of our prime cards are hearts? Well, 6 of them out of the 24 are hearts, because they're divided evenly into the 4 suits. So 1/4 of our prime cards are hearts, and 3/4 of our prime cards are not hearts. And so we figure out this piece of the problem by doing an expected value kind of problem. Okay, I expect this to happen 3/4 of the time. I expect this to happen 1/4 of the time. So I add those two products together, and what I'll get is 39 out of 204. Plus 12 out of 204. And that gives me 51 out of 204. Oh, isn't that interesting? That reduces 51 into 204 is 1/4. Okay, the probability of choosing a heart, given that I've already taken a prime number out of the deck, is 1/4. And so ultimately our answer is going to be this, probability of B times the probability of A given B. And so that's 6/13 times this probability that we just figured out times 1/4. And that's going to give us 6 out of 52, which reduces to 3 out of 26, which I think is more than 10%. 3 divided by 26, about 11.5%. Okay, so in review, we have to do the probability of choosing these as both events happening. One and the other is going to be the probability of one event times the probability of the other event given that the first event happened. This is the key. Sometimes that's going to be one definite probability, but in cases where there's overlap, you might have 2 chances. And so in that case, you'll need to do an expected value. When do you expect this to happen? When do you expect that to happen? Add them together for the total probability of that, and multiply times your probability of the other event. You can do this kind of problem for any situation where you have an and if you want it to be like this one, also you need to have some kind of overlap. Like, say, with cards, you can say choosing an even number and choosing a club. So that would have the overlap. Some clubs are even. hope that helps.